The sun converts 5 million tons of matter into energy every second. This energy from nuclear reactions within the sun is sent out into the solar system as light and heat. The Earth receives only a small part of this energy, which we see and feel in different ways. As the sun warms the Earth, the air is also warmed. The warm air rises and cool air rushes in below, causing the conversion of sunlight into another form of solar energy, wind. Today, this turbine harnesses wind to provide some of the energy for running an amusement park near Allentown, Pennsylvania. Another example of wind use today is this turbine, which helps light Clayton, New Mexico. Use of wind energy will increase in the future and help the United States to become more energy independent. But wind energy is nothing new in America. The idea of windmills was brought here by early European settlers and used in many ways to power grinding mills, and later to pump water for the steam locomotives that connected New York and San Francisco, and to supply water for farming. These early windmills were mechanical, often using a series of gears to harness energy. This energy could be stored by using the wind to pump water into an elevated storage tank. Gravity delivered the water whether the wind was blowing or not. This system was used for irrigation and household water supplies. With the coming of electric lights and appliances, wind systems were designed to generate electricity. A series of batteries was used to store this energy. Wind energy reached its peak in the United States in the 1930s and 40s, when at least 2 million windmills were in operation, providing an important source of energy for rural America. Many households had their own windmill and generator. Most of those generators produced 1 or 2 kilowatts of electricity. A kilowatt is 1,000 watts and can light 10 100-watt light bulbs. During the early 1940s, large wind generators which could provide power to many users were introduced. This power was distributed through a utility grid, a network of transmission lines which sent electricity from a central source to individual users. Towering above Grandpa's Knob near Rutland, Vermont, the Smith Putnam turbine fed electricity to a Vermont utility company. This system was designed to produce up to 1¼ megawatts of electricity. 1 megawatt equals 1 million watts, or enough electricity to light 10,000 100-watt light bulbs. But a cheaper, more convenient source of energy was sweeping the country, one that didn't require batteries, water storage tanks, or maintenance. Electric power lines from centralized coal and gas-fired power plants brought cheaper electricity to outlying areas, and wind energy was neglected. Today, increasing cost and other problems associated with conventional fuel make wind again a promising part of America's energy resources. In theory, it is possible to harness about 60% of the energy in the winds. This potentially usable power in the wind blowing across the United States in 1 year is more than the country's total power needs for that same period. Meet Marcellus Jacobs, whose work with wind spans the period from the peak of wind energy use in the 30s and 40s to the present revival of interest.
We just started developing our wind plant on the ranch there in Montana, 40 miles from town. We had no electricity, and there was no hope of high line for a good many years. So we started to devise a machine to make electricity from the wind, of which there was plenty, and built several test plants using Ford Model T rear ends. We built, I think, about a dozen and put them on ranches for 50 miles around there. And after 3 or 4 years, they proved so successful that we decided to make a business of it. Our past experience in developing and building wind energy systems proved that with the increase in energy costs, a new and improved type of wind energy system would be very practical and competitive with the energy costs of fossil fuel systems now being used.
There are problems with wind energy. It doesn't always blow when and where you want it, and quality machines are expensive. But solutions are being sought. The Department of Energy is testing small systems for individual use and large machines for centralized utility needs. The number of commercially available wind turbine models has grown from fewer than 20 in 1976 to 72 in 1979. Several of today's small wind machines are undergoing tests at the Department of Energy's Rocky Flats facility in Colorado. These tests are meant to provide valuable information to consumers, wind turbine manufacturers, and organizations affecting the use of wind machines, such as banks, zoning commissions, and insurance companies. There is also a Rocky Flats program to develop new advanced designs that increase the lifespan and reliability of wind machines and lower their manufacturing costs. The Department of Energy is working with NASA to develop large-scale wind machines. 4 large experimental turbines are generating power for electric utility companies. They are operating in New Mexico, Puerto Rico, Rhode Island, and North Carolina. Another Department of Energy NASA project is this giant machine. Because it will produce 2.5 megawatts of power, even in areas having more moderate winds, it will be more widely usable than previous experimental models. Private industry is also designing and building large-scale machines. On Cuttyhunk Island, Massachusetts, the municipal utility has lowered its fossil fuel use by replacing some diesel-generated electricity with wind power. This 200-kilowatt machine was developed entirely with private funds. Public utilities, too, are interested in wind. This turbine served as a prototype for development of a megawatt-scale machine, part of Southern California Edison Company's $2 billion wind energy development program. Much is being done to develop cost-effective, reliable equipment. But what about the need for storing excess power for low wind periods? Batteries work in some cases, but today another option exists. Martin Greenwald of Thompson Ridge, New York, gets some of his electricity from a 2-kilowatt windmill on his farm. The Greenwalds use what energy they need, and any excess generated by the windmill is fed into the utility grid, building up a credit on their account. A similar situation exists in another part of New York, New York City. While the urban environment is generally not conducive to wind machines because of high and unpredictable turbulence caused by tall buildings, it was here that the legal precedent was established to tie in small systems with the utility grid. Ted Finch, wind energy engineer, explains the importance of this action.
We established the right for people to produce power from decentralized wind systems and interconnect that wind energy conversion system with the utility company. Now that's an important precedent. It's much more expensive with small wind energy conversion systems to have battery storage. So especially with small installations, it's important to interconnect with the utility company, whereby they serve as a backup source of energy for you when your winds are low, and also where they buy back your surplus wind-derived electricity. This will enhance the economics of wind machines, and it's an important wind energy policy area to pursue.
The problems are being examined and solved, and wind is being used today. This turbine in Texas heats water. These ridge-top turbines light this cross above Denver, Colorado. And this egg beater turbine, a joint Department of Energy and U.S. Department of Agriculture research project, supplies energy for irrigation near Garden City, Kansas. And this one provides energy to refrigerate milk on a dairy farm near Fort Collins, Colorado. These 3 turbines convert sea breeze into power for a newspaper in St. Petersburg, Florida. Wind has great potential as an energy source in America, a potential that is in the process of being realized. As manufacturing costs decrease with mass production, as new technology and stronger and lighter materials are developed, and as the cost of conventional energy continues to rise, wind energy will find an even more important place under the sun.